Hey guys, welcome back to Thomas's Turf Tips. Today I'm doing the last of the series. Hey guys, welcome back to Thomas's Turf Tips. Today I'm doing the last of the sprinkler timer setup series. So we've done root depth, we've done soil type, and now we're going to do how to calculate precipitation rate. So I'm doing a test right now, and the reason I'm doing that is that I have changed my sprinkler setup. So that's one reason you'd want to do a precipitation rate calculation. Anytime you change the arc of a sprinkler or put in a new head, a new nozzle type, all of those things you need to run this test again. So I'm going to show you how to do that. So behind me we've got these Orbit catch cups. I find these to be the best in terms of running this test. So you can get those online, you can get them at big box stores. They're available most everywhere. So what I'm going to do is I've spread them out throughout the zone that I am testing right now. So you want to get them, you don't want to place them right next to sprinklers, but you do want to put them on the extreme portions of the zone that you're trying to cover. So then I'll run each zone for 10 minutes, and then what we're going to do is check the volume collected in each cup. After that, then we're going to go into the classroom. I'll show you what to do with the data. One thing that you might find helpful is to draw a little map of, so these are my sprinkler heads here. I've got 4 in the zone, and I've numbered where the cups are, or just graphically shown where all the catch cups are. So I've got 12 cups in the zone here, and I've drawn what looks to be like a Venn diagram. And what I'm showing here is the coverage that each sprinkler head has and what catch cups are covered by that catch head. So some of them are catch cup. Some of those are shared by 2 different sprinklers. So you can see catch cup 3 and 10 are covered by these 2 sprinkler heads here. That's important to know if you need to make adjustments to your system. And we're going to show that in the classroom too. But if you don't have good system efficiency, then you're going to be wasting water, or you're going to have dry spots or wet spots in the zone. We want each of these, the name of the game is to get all of these catch cup volumes to be roughly the same, to have good system uniformity. So in a minute we'll get all the volumes from each of the cups, record. We'll have 12 data points, then we'll take it back in the classroom and I'll show you what we do from there. Okay, so the sprinklers have run for 10 minutes. Now I'm going to go around and record all the volumes here. So on this one, let's see here. We've got 10 milliliters. So I'm going to document that. Another tip is just to make sure you don't measure the same thing twice, and just empty the cup. And so far I've got 4, 10, 10. So you can see this number 1 is low. So we've already got something that we may need to adjust. Let's see. Okay, I went into the classroom to enter the data and figured out that we've got a problem. This head's, the catch cup readings are almost half of what the rest of the catch cup readings are for the other heads. So I'm going to show you how to fix it. When it's low like that, your coverage uniformity is low, so you don't want that to happen. So this is called a nozzle tree here. So this is Rainbird's version of that. So they're labeled by the flow rates that they allow. So I'm going to take a look at this nozzle here, and we're going to see what the flow rate is, and then we'll double that to get a better uniformity. So you get a tool like this, and you can just pull the head up like so, and then
we can unscrew the nozzle. It's held in by that set screw. Cannot see it with my glasses on. Okay. Okay. All right, so this one says 1.5. So we're gonna go find, this is low angle, so I don't want a low angle. Get a 3. Here's a 3. I'm just going to pop that in and run the test again. You've got to get this set screw low enough that it'll hold the nozzle in. This is also, you can run it in far enough that it'll stop or shorten the distance of throw too. All right, so we're all set. We'll make sure all the cups are empty and run a test again. Then we'll come back to the classroom and I'll show you the results.
Okay, so welcome to the classroom. What I'm showing here is the results of the trials I ran. I ended up running 3 trials to try to increase the distribution uniformity that you see here. I was successful in doing that, and how I did that was I changed out nozzles in 2 heads to make sure that I got as close of a result for each cup in terms of precipitation rate. So by the way, this is a spreadsheet I just set up for illustration purposes. I will leave a link to a website that does something similar so that you can use that when you're doing your calibration process. But I'll walk you through how I did this here. So first you have to put in the size of the catch cup that you have. In my particular case, mine are 16 inches squared for the area that's collecting into the throat. And then I ran my test for 10 minutes. What you see in this column here are the volumes collected for each cup, and then that calculates the precipitation rate for each cup here using the volume collected, the test duration, and the catch cup area. That's how it comes up with precipitation rate. My final result was 0.259 inches of precipitation per hour, with a distribution uniformity of 62%. So that's what you would put into your controller for the controller settings. But I did want to show you how we improved over time, and you should do this as well. If you have a distribution uniformity of 36%, that's fairly low, so you want to try to increase that as much as possible. You can take it as far as you want to. You can fine tune it over and over and to get to a higher percentage. In my case, I only did 2 trials, so I went from 36% to 62% in the final trial, and I did that through changing out of the nozzles on 2 heads. So that's it, folks. That's how you calculate the average precipitation rate and the distribution uniformity. You'll put that into your smart controller, and away you go. Thanks for watching. Talk to you next time.